There are two methods for dividing polynomials. The first one that I've already done is long division. In this video, I'm going to show you what's called synthetic division. Now, with long division, you can divide any two polynomials, but with synthetic division, you need to make sure that you are only dividing by either x plus a number or x minus a number. Now, in this example, I'm dividing by x plus 3, so I'm good. That means I can use synthetic division. Anytime you divide two polynomials, you need to check for two things first. Number one, it needs to be in standard form. This polynomial is not in standard form, so I'm going to have to rewrite it. The second thing that you need to check for is that every term is present. In other words, if I start with an exponent of 5, the next term must have an exponent of 4 and then an exponent of 3 and so on. If you're missing any terms, you need to fill it in with a 0. So I'm going to go ahead and rewrite my polynomial first. Now you'll notice I go from x squared to a constant 4, but there should be an x between x squared and the constant term. So I'm going to put plus 0x after my 12x squared. So I'm just going to give you a second to catch up, but all I've done is rewritten this in standard form, but I've also filled in a 0 where I was missing a term. Now with synthetic division, what I'm going to do is put a little box in the upper left corner. In that box, I'm going to put the opposite sign of this number that I just circled. So if x plus 3 is what I'm dividing by, I'm going to put a negative 3 in the box. If it was x minus 3, I would put a plus 3 in the box, or positive 3. Now what I'm going to do is write each coefficient. So I'm not going to write any of the variables. I'm just going to write each coefficient in order that I have them written in this x to the 5th minus 2x to the 4th and so on. So the coefficient on x to the 5th is 1, followed by negative 2, negative 10, and so on. Now I'm going to skip a line and then draw a line. So again, if you don't put that 0, your final answer would be wrong, so that's why it's important to fill in the missing terms. Next, I'm going to go through with the synthetic division process. I'm going to bring down the first term. In this case, it's a 1. So I'm just rewriting that. Now that number that I just brought down gets multiplied by the number in the box. 1 times negative 3 is negative 3. That's going to go into the next column. And now I'm going to add that column. Negative 2 and negative 3 is negative 5. And now I start over. I take the negative 5 and I multiply it by the number in the box, which is a negative 3. Multiplying negative 5 times negative 3 gives me positive 15. So I put it in the next column and I add. Negative 10, positive 15 is positive 5. And I keep going. 5 times the negative 3 in the box is negative 15. Add the column. 12 and negative 15 is negative 3. Multiply by the number in the box. I get positive 9. Add the column. I have 9. We're almost there. Multiply by the number in the box. I get negative 27. Add 4 and negative 27 would be negative 23. And we are pretty much done. All I have to do now is rewrite it, and I have my answer. Now, because my polynomial started as a degree of 5, and I divided by x plus 3, so a degree of 1, my answer must be a degree of 4. All these numbers that I just found are the coefficients in my final answer. So I have 1 x to the 4th, minus 5x to the third plus 5x squared minus 3x plus 9. And this last number on the end will always be your remainder. So our remainder we write as minus 23 over x plus 3 because that's what I was dividing by. And we have our answer. Normally I wouldn't write the 1 in front of the x to the fourth. You can drop it, but this is our final answer.